Okay, it is now officially May 20th, 2023, and me, Mrs. Genesis, are on a schedule now. And we are going to go do study. We kind of slept in a little bit. We were supposed to start studying at 7, but we woke up around 10. We added an extra hour, but it's okay. We did really good. Mrs. Genesis and I are doing very good. More so Mrs. Genesis, because I'm already accustomed to studying and everything, but she's now on a schedule where she has to do this stuff so she can get work done. So what we did last stream, we were supposed to go through these rules here about the show. So we are now on software development at night. Study Python programming and excel your knowledge in software development and grasp a better understanding by gathering information from the internet and self-teach yourself. So here we have a bunch of goals that we need to complete. So we're gonna start with the first one. We're gonna read at least one chapter from Automate the Boring Stuff. I think we're gonna read chapter 2. How's that sound?
Yeah, we read chapter 1 already.
Okay. So we're gonna go head over to what's it called?
Automate the Boring Stuff.
Yeah, so go to chapter 2.
Okay.
It doesn't matter which one. I think we know what flow control is, but we're gonna read it on it, okay?
Yeah.
I'm gonna have you read this. You're gonna have to read all of it because people are sleeping over here, so I guess we can take turns. Okay? So I'll go first. Tell me when you're at the page and we can continue.
Well, alright. I'm on it.
Okay. Sounds good to me. Get food overdue. I think, yeah.
Yeah. Let's keep reading. You ready?
Companionship overdue. Can I? Oh wow! It says get food overdue. Okay, we did get food. I don't know why it's saying that. Okay. Whenever you're ready.
No, it means the companionship part. We got food during the
Okay, we gotta keep going because we're on a schedule. Yeah. So, read flow control.
Alright. So you know the basics of individual instruction and that a program is just a series of instructions. A programming's real strength isn't just running one instruction like after another like a weekend errand list. Based on how expressions evaluate, a program can decide to skip instructions, repeat them, or choose one of several instructions to run. In fact, you almost never want your programs to start from the first line of code and simply execute every line straight to the end. Flow control statements can decide which Python instructions to execute under which conditions. These flow control statements directly correspond to the symbols in a flowchart. So I'll provide a flowchart. Wait. I'm gonna reread that. These flow control statements directly correspond to symbols in a flowchart. So I'll provide a flowchart version of the code discussed in this chapter. Figures 2 to 1 shows a flowchart for what to do if it's raining. Follow the path made by arrows start to the end.
So the diamonds are the conditions and the rectangles are the the clauses, right? What to do.
Yeah.
So
What's with the
if it's
left?
raining, is it raining? That's the condition. The condition is it raining? If it is, do you have another? Here's another condition that says, do you have an umbrella? If you do, wait a while. If you do have an umbrella, go outside. If you don't, wait a while, right? So
Yeah.
these are just conditions, and these conditions are the second part of Python programming, where it actually makes you make more intelligent decisions. Okay, you can read in a flowchart under that.
Alright. In a flowchart, there's usually more than one way to go from the start to the end. The same is true for lines of code in a computer program. Flowcharts represent these branching points with diamonds, while the other steps are represented with rectangles. The starting and ending steps are represented with rounded rectangles. But before you learn about flow control statements, you'll need to learn how to represent those yes and no options, and you need to understand how to write those branching points as Python code. To that end, let's explore Boolean values, comparison operators, and Boolean operators.
Okay, so when we talk about Boolean values, we're talking about true and false. When we're talking about comparison operators, it's how we compare values. Comparison. We compare values to one another, and comparison operators evaluate to true and false as well. And then we have Boolean operators like and, or, and not. That operates on a Boolean value scale. So on those values, not scale, values, excuse me. So Boolean values are crucial when it comes to programming because they help us to actually see if a condition is true or false, right? You can use Boolean values. There's only two Boolean values, right?
Yeah, true and false.
Yeah. And then now I'm going to read, you could read this part here. You can read the Boolean values. I'm going to make you read all of this actually. Okay? Because I know this shit, So go ahead.
Boolean values. While the integer, floating point, and string data types have an unlimited number of possible values, the Boolean data type has only two values, true and false. Boolean is capitalized because the data type is named after the mathematician George Boole. When entered as Python code, Boolean values true and false lack the quotes you place around strings. They always start with a capital T or F with the rest of the word in lowercase. Enter the following into the interactive shell. Some of these instructions are intentionally incorrect and they'll cause an error messages to appear.
Okay. You can skip that. All that's going on is you can store Boolean values instead of variables. And if you try to type a Boolean value without a capital T or a capital F, you'll get a traceback error. And we can see that being demonstrated here on line 2. And on line 3, it's saying, you can't assign to a keyword. So true is equal to 2 plus 2. You cannot, in long story short, you can't use Boolean values as variables and constants. So that's all that line 3 is. Line 3, 1, 2, and 3 are demonstrating. So go ahead. Like any other value.
Like any other value,
Mhm.
Boolean values are used in expressions and can be stored in variables. If you don't use the proper case or you try to use true and false for variable names, Python will give you an error message.
So just like I explained. All right, so I'm going to read comparison operators, okay?
Okay.
So comparison operators, also called relational operators, compare two values and evaluate down to a single Boolean value. Table 2 to 1 lists the comparison operators. So here are all the comparison operators within Python. I'm going to say in Python because I only have experience in Python. I think this is also in Angular, Java, and TypeScript, JavaScript. So we have equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. this is 1, 2, 3, 4, 5, 6. There's 6 comparison operators. Comparison operators operate on values, and it makes its assumption on these. They're more so used in a term of conditions. They're more commonly used in conditions, but you can use them for a lot of things. You can just use them for you don't have to only use them in conditions. You can just use them any way you like. But in a sense of conditions, they're more widely used on conditions. So these operators evaluate to true or false. So these comparison operators, so if we say 2 is greater than 2, that'll be false. 2 is greater than 1, that'll evaluate to
no, yeah, true.
True. What do you mean? So
No,
it'll
I
evaluate
got
to true.
confused.
1 is greater than 0, that's true. Stuff like that, you know. So these operators evaluate to true or false. Go. That's, and as you can see, you know, it shows that. And then you see, as you might expect, the equal to evaluates to true when outside is the same. Yeah. So I'm going to read this. As you might expect, equal to evaluates to true when the values on both sides are the same. Not equal to evaluates to true when the two values are different. The equal to and not equal to can actually work with values of any data type. Okay, so I'm going to go down. Note that an integer and floating point values will always be unequal to a string value. You know, the expression 42 is equal to the string version of 42 evaluates to false because Python considers the integer 42 to be different from the string 42. The less than, greater than, less than or equal to, or greater than or equal to operators, on the other hand, work properly only with integer and floating point values. So we can tell. And here's the difference between equal to and the assignment operator, right? So the first, I don't think we have to read all this, but I'm just going to summarize it. The equal to compares two values together, and the assignment will actually puts the value to the right into, it assigns the value to the variable. So the single equal is an assignment operator. It's an assignment statement. It's used for assignment statements to assign, right? So, and then we have, yeah. And then, you know, and then I don't think I have to explain this because it's the same thing. And then this is talking about Boolean operators. Boolean operators, there's 3 Boolean operators: and, or, and not, used to compare Boolean values. Like comparison operators, they evaluate these expressions down to a Boolean value. So what does this mean? So Boolean operators, as they say in their name, they operate with Boolean values. Now, remember, anything that evaluates down to a Boolean value is technically a Boolean value. So if we were to say 2 is greater than 1 and 1 is less than 5, remember, because comparison and relational operators will evaluate to Boolean values. So we can actually use Boolean and comparison operators in as a junction together. We can mix them together. Okay, mute. So that's what that means when we say Boolean operators. There's different types. I don't think we have to go read all this. I've done my knowledge and I've studied on this. So I think I can let you guys know. Long story short. So yeah, long story short. And the two values that are assigned to an and will evaluate to true if both values the and operator will evaluate to true if both values assigned to the and are true. The or will evaluate to true if both values assigned to the or operator, if either of them are true, so there needs to be at least one true, then it'll evaluate to true. So it can be true or false, false or true, but if it's false or false, then it'll evaluate to false. And then we have not. This is just a nesting operator. It just simply evaluates to the opposite Boolean value. And we can nest these operators as much as we like. And here's an example. I'm going to try to show an
You muted yourself.
I'm not muted.
Wait, hello?
Yeah, I'm here. Oh, God.
My loves.
Okay. That's what I'm doing. I'm recalling. Alright. Okay. Can you hear me? Can you hear me?
Yeah, you muted yourself.
I did not mute myself. I don't know what's going on, but we're back. Okay. All right. So technically, let's go take a look. All right. So I'm gonna go ahead and screen share real quick.
Okay.
Let's go take a little screen share. All right. So here we have the Python interactive shell. So long story short, I'm gonna leave this for future reference because we're talking about it. So we have and, or, and not. That's what they're talking about. These are Boolean operators. We're starting with and. Let's start with the comparison operators. So we have greater than, less than, greater than or equal to, less than or equal to, and not equal to, right? Yeah. So we could say 2 is less than 7. The comparison operator is the symbol in the middle. That is the relational operator, and it operates with 2 values. Doesn't matter what it is. And we could say, yeah, see, it evaluates to true or false. Just use common sense. I mean, 2 is definitely less than 7. So we can actually use relational operators with Boolean operators. So we could say 2 is less than 7 and 3 is greater than 2. So now we have this system going on here. I'm going to zoom in. We have this system going on here. And technically, the AND operator is going to evaluate to true if both values, both conditions, are true. So this is going to evaluate to true, as you can see. And then we're going to test this out with, but the moment that this, one of the values, one of the expressions are seen to be evaluate to false, then we're going to get false. So 3 is greater than 1. I mean, 3 is greater than, let's see, I don't know, let's wait. True, right? So that's going to be true. So 3 is greater than 7. That's false, right? So as you can see here. So and needs both values that it's working with to be true. That's how it works. It's like saying I'm only going to be true if both of the values are true, right? If both of the conditions evaluate to true. And or is just exactly what its name is. As you guys can see, if we put or here, 2 is less than 7 or 3 is greater than 7. One of these are true. One of these expressions are true, and one of them are incorrect or false. I'm sorry. So it's going to evaluate to true because all or really wants is for one expression, and it just needs one true value. That's all. And again, you would use this in the sense of conditions, and yeah. And then we have not, the not operator, and all this simply does, let's start off with true. If we put true, that evaluates to true, but the moment that we put not in front of it, this is going to evaluate to false. So not true, false. And we can actually nest Boolean values. So we can say not true. This would be true again. And then we could say not. This would be false again. There are reasons to do this, but most of the time, some people just kind of use it once, you know. So
Yeah.
you can nest these. That's all that's explaining.
Hmm.
Okay. Skip all that. Mixing, we talked about that. All right, and now we actually go to elements of flow control. Okay, and I'm gonna leave it to you, Mrs. Genesis, to read that part.
All right. Elements of flow control. Flow control statements often start with a part called the condition and are always followed by a block of code called the clause. Before you learn about Python-specific flow control statements, I'll cover what a condition and block are. Conditions. The Boolean expressions you've seen so far can all be considered conditions, which are the same things as expressions. Conditions is just a more specific name in the context of flow control statements. Conditions always evaluate down to a Boolean value, true or false. A flow control statement decides what to do based on whether its condition is true or false, and almost every flow control statement uses a condition.
Okay, so let's go take a look at this inside of like a file editor. So if we open up a random one, I don't know, we're just gonna do like a random condition.
Make sure to put it on Python.
No, it doesn't matter. It's already automatically on Python. I'm gonna throw this away. This is just a sketch. Okay, so if we do if 2 is greater than 1, then I don't know, print hello world, right?
Yeah.
So here's okay, so if we look really carefully, I'm gonna put this a little bit down here. So we're gonna just start with if. I don't think we're gonna read all this stuff. I think I'm just gonna teach it to you this way. So yeah, just to save time. So if is the most common flow control statement. It's the most common one. It's the first one that you should learn. You should be learning. And what we're saying here, so there's a lot of things going on here. So here's the statement, and here, this right here is an expression, is the condition, right? The condition is, you're probably thinking, well, that's an expression. Well, yeah, I mean, if it was outside of this actual conditional, then it would be considered just an expression, right? Like
Yeah.
if we were to say, because there's a difference. If we go over here and we do expression 2 is greater than 1, and 1 is less than 5, then yes, this is an expression right here. But if the moment we put this over here, it's a condition. Okay, does that make sense?
Yeah.
So if 2 is greater than 1 and 1 is less than 5, then you know. Now, the if statement will evaluate to true if the condition is found to be true. Once the condition is found to be true, it'll execute this block. This you see this yellow block here?
Yeah, the
These
clause.
yeah, these are just no, these are not. This is not
Wait,
the
no.
block. This is the indentation. And in Python there's 4 spaces to validate one indentation in Python. So we have 1, 2, 3, 4. That's 4 spaces. And then this is the block. Now we're inside of the first block. So everything you see in here, this is the clause. This is the body of the if flow control statement. And in here is technically just the code that is going to be running if this conditional is found to be true. That's all. And the rest is very easy. You can add extra conditionals with elif. So else if, you know, Genesis in Genesis pass, it doesn't matter, we're just gonna leave that there. Okay, so elif, this is in the next flow control. what elif is saying, well, the meaning for elif is an extra conditional that you can add to your flow controls. You can have as many of them as you'd like. It's as infinite as much as you like. And else if is saying else if, Genesis in GenesisGir, this is a condition. Don't even think about the Genesis. This right here is the condition right here. And if that condition is found to be true, then it will, as you know, throw us inside of the elif clause of this particular elif clause.
Yeah.
You get that so far?
Mhm.
Hey, pretty easy stuff. I mean, and then the last part we have is an else. So this one's really important too. So if this condition is found to be false and this condition is found to be false, it will throw us inside of the else clause. The else clause will only execute if all the other conditionals are found to be false. Right? So
Yeah.
So what does this mean? So that means this condition was found to be false. And if this condition was found to be false, we can actually do an examination. If one is less than and one is less than 0 and 2 is greater than
7.
7, yeah, we'll put 7. So this one would fail, and then if we put we would just remove all this stuff. We can actually remove all this. Then yeah, as you can see, then only will this execute. This will execute here. And once this executes, it will run all the code within here. We can print all conditions were found to be false. That's all this else is for. It's a backup in case all your other conditions fail. That's all. And as you can see here, that. Now, the next thing they're probably going to teach is while loops. We have while, and then we have for. I'm not going to get too deep into it, but I feel like these are just loops. Just know that these are loops.
Iterators.
Or iterators, yeah, or another fancy word for loop. And these both take conditions. Both of them do. So while 2 is less than 3, I want you to keep looping everything inside of this. So once this condition is found to be false, it will break out of this loop. So what does that mean? So the condition is true right now, right?
Yeah.
So that means it's going to keep looping. Think of it like that. This is its life force. As soon as this condition is found to be false, it's gonna break and it's going to escape it. Only then. Some people get confused that, oh, well, it's gonna keep looping if it's true. Yeah, that's exactly. That's exactly what a while loop does. It stays inside of its iteration process if it's found to be true. Some people, if you want to keep this infinite looping, they just set true here, right? Because that means they just want it to keep looping over and over. And only if, now we're getting into the subject of break statements, only if you put a break statement, once the program execution hits a break statement, only then will you break out of that loop. And you could have conditions inside of while loops too.
Yeah.
You could do that. That's possible. So there's that. And then we have for loops, which are, so now we know while loops are iterators. They can loop infinitely. And we have until broken out of, or the condition is found to be true. And then we have the for loops. So for I in range of 1 to, I don't know, 100. What we're saying here, this will iterate. This is going to iterate a certain amount of times for whatever, right?
Yeah.
That you set it. So this will iterate a specific amount of times. So that's what this is used for. And you can iterate through arrays. You could iterate through anything you really want to. So how this works is that a for loop has a variable. It has the statement, a variable, an in keyword, and a value you want to iterate through, right? So right here, we're iterating through the ranges from 1 to 100. And it's going to iterate from, now we can print I, and what's going to happen here is actually put this to 0. And I think it's 101. I might be mistaken, but all you need to know is that what this is going to do here, it's going to say for, I want you to iterate through the range of the integers of 0 to 100. And then it's going to store these iterations inside of the variable. So all the numbers, so like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's going to store all of those values inside of the variable. Okay.
And
then,
it's just gonna keep on reiterating
until the condition, yeah, it's not gonna do it forever. It's gonna do it until 100.
Yeah.
So if we had a list and we had like 5 objects in there, I could show you an example. We had a list. Let's call this list. It's equal to some list. And this list contained numbers. Let's see. 1, 2, 3. What's going to happen, we could actually iterate through this list. It doesn't have to be range. We can put that there. For I don't know, n will stand for number. Actually, let's just put that there for number. For number in some list, the for loop, what it's gonna do, it's going to iterate through all of them. It's going to iterate this list, and it's going to well, that's not a list. Now it's a list. Sorry. And a list is just a data type that can contain multiple values. Yeah. So here we have this 2 types of loops. Okay, so does that make sense? Okay. Okay,
yes,
great. We can move on.
While loops
We killed
loop
a lot of stuff, yeah.
Proven false, and for loops iterate a set amount of times.
Yes. They iterate through anything. So if you have a grocery list, it's going to iterate through each element in that list or through that. And it's going to return you each iteration. Does that make sense?
Yeah.
And you can have the option to display that with the variable that is locked in and designed within the feature of the for loop. So then we have break statements, like I talked about. And here's a flow chart of how I think while break statements work.
Yeah.
Right. And then continue statements. I forgot to talk about continue statements. Continue statements, all they will really do, they just reiterate prematurely. So once a program execution hits a continue statement, it's going to reiterate prematurely. This is great if you want to iterate prematurely, right?
Yeah.
For whatever, right? So let's say, that's all you need to know. I'm not going to go into too much context, but that's what it practically does. It just, once a continue statement gets hit, it throws the program execution all the way back at the beginning of the loop so it can start its iteration once again. You don't have to read that. Yeah, we talked about this. Okay, starting, stepping. Yeah, all right. And range, we're going to talk about range. So what is range? Range, let's go read here. I think they have talked about range. Let's see. Loops in the range function. So The best way you can think of range is it's exactly what the name is. It's a range, right? But they have these arguments: the starting, stepping, and stopping. So we're gonna put this back over here. We're gonna put this here. So we're gonna say range. Let's actually read what it is.
Okay.
I think it tells you. Return an object
Yeah.
that produces a sequence of integers from start, stop, and stepping. Okay, so it starts. I think this guy got it wrong. No, he got it right. Okay, so start, stopping, and stepping. So the first integer that you throw here is going to be where the integer is going to start. The next one is stopping. That's strange. Oh no, step. So how much you want to step by. So how much you want to step in that sequence. So if we're gonna count up, let's just put 2 for now.
Okay.
Let's put 101. That means this is the stop at, right? If there's only 2 values, that means there's a starting and then there's a stopping values. But as soon as we put a third one into the equation, let's say we want to step by 10, then that means this is going to iterate by 10. So it's going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Once it reaches 100, that's this 101 is the stopping. We want it to stop at 100. You're probably thinking, well, that's 101. It stops at, but not including.
So if it were to stop at 100, it wouldn't include 100. The last thing that would be included would be 90, right?
Yeah, because when we say stop at 100, what does that mean? Stop at 100. That means that's the wall. You know, how are you going to get to 100 if that's where you stop at 100? You know what I mean? Does that make sense?
Yeah.
So if we want to stop at 101, we would put 102. Because if we want to stop at 101, if we stop at 101, we're stopping at 101. We can't make it to the value 101 because we have ultimately stopped at 101. So that's just what this is. And you can step by 5, you can step by 2s, you can step by whatever, any value you want. For now, we're just going to be stepping by 1, right?
Yeah.
Now going down, importing modules, you can read that.
All right, let me go down to that.
This water smells fucking weird. Oh my god.
It's not good.
I never thought I would say it. It legitimately smells like pee. I'm thinking that they reused, dude. I swear to God.
It's probably tap water then.
No. Okay. Okay. Go ahead.
All right. Importing modules. All Python programs can call a basic set of functions called built-in functions, including the print, input, and learn functions you've seen before. Python also comes with a set of modules called the standard library. Each module is a Python program that contains a related group of functions that can be embedded in your programs. For example, the math module has mathematic-related functions. The random module has random number-related functions, and so on. Before you can use functions in a module, you must import the module with an import statement in the code. An import statement. In code, an import statement consists of the following: the import keyword, the name of the module, and optionally more module names as long as they are separated by commas.
Yeah, so we're gonna stop there. So, long story short, you can actually import modules inside of other modules. The modules that you're working with, inside of Python, technically are just other Python programs. Long story short, and even functions inside of modules are technically still modules in a way. They're like mini modules. So if we want to import stuff, the import keyboard allows you to import modules, built-in ones or third-party ones. So if you want to use functions, methods from other modules, then you would definitely use the import, or you could use the from. So from, yada yada yada, import. Yeah. So here we're going to import, I don't know, sys, right? And if you want to import, you could actually in one line, you don't have to go down here and say, oh, import. To import your next one, you don't have to do import random. You could actually just put a comma and then put random there. It does the same shit. You see that?
Yeah.
Now there's from keywords, from import statements. So from typing, doesn't matter what it is. From typing, import. I'm just showing you from import type. This is how you can import specific things, specific functions, methods, variables, you name it. So when you import with the first method, you import everything from that module. But if you want to import a specific thing, a specific method, then you would use the from keyword. So it does kind of matter. So we're going to say importing. Okay. Does that make sense? And you can also, you could technically, if you want to install a bunch of newer Python modules, third-party ones. When we talk about third-party, that means something that is not native. So something that you have to download on a website or something like that of this nature. A great place to go look for third-party modules is the Cheese Shop. This is for Python users. Yeah, they're all free. You can find a lot of cool stuff here. You can even log in and register and stay updated with like new Python modules. We could even check right now. We can check browse projects, and here you can browse from framework, from topic. We have chat, Unix, mailing list servers, stuff that are already pre-created for you, data environments, black boxes, JSON. These are all Python projects, Python.py files that come with pre-written code that you can use for your advantage. Right? So go back here. I'm going to link this into chat. So if anyone is curious, or if you forget my love, just go to my YouTube channel and go read it. Go check it out.
Thank you, my love.
Yeah, so I mean, well, how do you install these Python modules? The first things first, if you want to install a third-party Python modules, because if we're talking about the sense of importing, you just find a Python project, a Python module that you want to install. Let's go to topic. Let's say, I don't know, ICQ, you know, and then we have this plugin here. We have pip install non-bot plugin botwiki. We would just copy to clipboard, or you can just hover and copy it. And sometimes these work, sometimes they don't work. I mean, we'll see if this one works. I'm going to install this one. So you can install it from within your Visual Studio terminal. So just go to terminal, new terminal, and then just copy and paste that. It's good practice to put --user so you don't run into any permission problems sometimes. Yeah. So if you fail the first time, put --user. This will just give you more admin privileges to install the actual plugin. And now, see, as you can see, it's installing all the dependencies and everything, and it's going to hopefully successfully install everything. And let's see.
Let's give it its time.
Yeah, it's installing Playwright. It's installing all these other stuff, and it's done. It's been installed. This is we've installed a third-party plugin. Now, if we say import non-bot, it's there. See that? It comes with a bunch of cool stuff. So it comes with non-bot plugin, APS scheduler, non-bot plugin, all these cool stuff. So,
Yes, we can.
you know, and then if we go to what does numbot do? We can hover over it and it tells you, hopefully, if in his documentation. It's a bunch of plugins, right? Stuff there. So that's what importing stuff is. And if we actually hold control and press left clicked on the actual thing, we can actually go inside the code and see the module itself and see what's going on. This person writes in Japanese, as we can tell.
It's Chinese.
Chinese, excuse me.
Or Mandarin. It depends.
Yeah. But as we can tell, another foreign language. And we could see all the stuff that they wrote. So what are modules? They're just Python scripts. They're Python scripts, and you can actually import other Python scripts into your main Python scripts to use them to your advantage. This is why we import stuff, right? Because if I really wanted to, he has a function here called get adapters. For whatever reason, I mean, I wouldn't really be doing this, but in a sense, if let's say you are doing this, if you want to get a specific function, you would do. All right, so here we say get adapters. I think if we do get underscore adapters, see, you see, we can't access it unless I'm spelling it wrong. Let's see, get underscore adapters.
Isn't it supposed to be the module name then the... No.
It's not defined. If we do that, see, it's not defined. That's why you have to do from nonebot import get adapter. See this function? Boom. And then now we have access to it.
Oh.
See that? So now we actually have access to that particular function. Now, it's not get adapters. Here's get adapters. And now you can use all the logic from in here and so on. Okay? So that's import statements, right? And I'm going to put this down in case, you know, just to give credit, this was actually created by this guy right here. Don't know his name. You try to find his name. But here's this page. I don't know what this particular plugin does. I don't think I'm ever going to use it, but it was going to, you know, if anyone wants to use it. And here you go. I'll put pip. I'm just going to bring you to the page. Link the page. Okay, there you go. And I'll put the command. I'm not going to put the command because maybe nobody will want to. I mean,
you never know, my loves.
Yeah, you never know. Okay, we can continue doing this. Thing's loud. Like, I wish they would make it like it not as loud, but I don't know. It might be too loud. Alright, let's continue.
Alright.
Yep, I explained this. Exiting a program with the sys function. So sys is a module. I talked about this earlier. We imported sys. What does sys do? It comes with a bunch of cool stuff, but if you want to end a program on your terms and not when the program actually hits the end of a program, if you want to make it end early whenever you choose, you would do that with the sys.exit function. And once it hits the sys.exit, the program will end prematurely. That's all it does.
Yeah.
And then that's it. That's it for this. And we're done. Okay. Okay, you can read this part. I'm gonna go use the bathroom. You can go ahead and read that part, okay? Because it's still recording, okay?
Alright. Let me go down.
Or you can read it yourself.
I'll read it out loud. Alright. By using expressions that evaluate to true or false, also called conditions, you can write programs that make decisions on what code to execute and what code to skip. You can also execute code over and over again in a loop, while a certain condition evaluates to true. The break and continue statements are useful if you need to exit or loop or jump back to the loop start. These flow control statements will let you write more intelligent programs. You can use another type of flow control by writing your own functions, which is the topic of the next chapter. We're done. Operators. Oh. Right. Oh. I guess it's true. No. Oh, so curious. Yeah, I'm just doing the practice questions to myself right now.
Okay, my mic should be on.
Yeah.
Okay, so the practice questions. Yeah, I think we already know this. Yeah, so I think we finished that one, did we not?
Mhm.
We can safely say it is. Read a chapter. What else did we do?
You streamed.
Yeah, stream at least what time of day? Yep. Now we have to create a script that has a password system. We could try something else. We can change it to something different this time. Maybe
That makes please. Oh.
okay, that's easy. Okay, so close this, close that. Okay. I'm gonna make a session. I'm gonna invite you.
Alright.
Right screen.
Alright. Let's give this its time. This isn't working at all. Alright. I'm loading in my loves.
Yeah.
I
So
need to
just
take it
make 30 lines of code using the rain function at least.
Okay. Let me find the folder. Wait a minute. Wait, what do I call it?
Doesn't matter. Anything you want.
Alright. Mm-hmm. I'm trying to figure out how I can use it. Okay. Make a list. Oh, I didn't close out this. There we go. Let's see. So, I think I can just come and just go by 10 and then we'll go by 5. So, 1, 2 of your 50. Yes. Oh, I'm almost done.
Yeah, try not to overcomplicate it, you know?
Yeah, it's fairly simple.
Yeah, it just has to be 30 lines of code long, that's all.
Wait, did I put name? Oh my god. I said I put name. No, what the? I need to stop following you. No, I was never. Wait, I was never following you.
Okay.
I got 5, 10, 15. No, 5, 10, 50. I don't know. I can just kind of copy this and. Oh. No crap. Wait, what the hell happened? Wait, am I still in? Okay, yeah, I'm still in. Thank God.
Okay, I'm done.
Okay. I'm pretty sure I'm done. Let's, yeah. Well, it's not technically skip counting. Yeah.
I'm gonna use enumerate. Okay, and I used the enumerate function as well, so that's nice. Okay, not really making use of these here, but it's nice to have a little bit of practice of object constructors and initializers. Okay. Okay. You finished, or are you still going?
Well, no, I'm technically done. I'm just looking for something else to add, but I don't think I'm gonna add it. Okay, let's just delete this one entire thing. Look for another one.
Yeah, that's done. I'm not gonna spend too much time on it. Okay, I'm done.
Me too.
Okay, or we can take a look at each other's stuff. What is yours called?
Miss Genesis Range Happy Face. I couldn't think of anything.
Where did you save it?
In the daily code sketches. Oh.
Okay, let's see. Okay, I'm gonna run it. Would you like to skip count by 5, 10, or 50? Let's put 5. You successfully skip counted by 5. That's amazing. You can try
Wait,
mine out. It worked.
Wait, it did? I can't see, so.
Oh no, it's 0.
Oh wait.
It didn't skip by 5 though.
Let me see. Let me look on your screen.
Tell me when you're ready.
I'm ready.
Oops, hold on. Let me restart. Put 5. It doesn't iterate through all of them.
Wait, what? Oh. Wait. It goes by. Oh. So. I'll figure that out. Let's see. Oh wait! I think I might have gone to step in the stop confused. Probably. Because it starts, stops, and step. Let's see, actually. I'm actually curious to see if that would work.
No, it starts, stop. It starts, step, and stop.
Oh, then.
Alright, so you have responses. That's an array of strings. And
Yeah.
and then we have 5. So if the user, it's going to evaluate to. Okay, responses. The index 0. So yes. So if you would rather do if response in. Try if response in responses index 0. That's capital. That's capital. Jesus Christ. There we go. Let's see. Let me test that out. Yeah, it's the break statement. It's probably the break.
Okay.
Remove the break.
Oh, sure. It might. Yeah, probably.
No, that's not it either. So here, just what's going on for n? Print n. All right, well, it's your code. You're figuring it out.
Oh, runs, but.
What you could do, you could print and see what result you're getting after you put the result in. 5.
5.
And then you can check the type because that really does matter. Because if it's an integer, that goes a long way.
No, but thing is, input would
It's a string. It's a string. Yeah. I know, but you just always want to double check sometimes. Alright, so we know that that's doing that. I'm going to remove this now. We know that the response is a string, 5. So response is equal to. You can go ahead and put equal to back. You don't have to put in. Both work, don't matter. If response is equal to responses at the array, put 1 instead of.
No, but 1 is off.
Yeah, but just to check it out. I don't know. It's a really stupid assumption. We're just debugging right now. Yeah. So it does iterate, but it stops. That's because you're skipping. Okay. Okay, so I'm thinking, yeah, put that on 0. So it's iterating. So just remove the 5. Stop stepping by 5. Just put that, and then remove that comma. And then put a space always after your commas. That's single space convention. There you go. That worked.
No, but that goes by 1, so that's the problem.
Yeah, but now we know what the problem was. It's actually iterating. And then you would want to put 101 because you're stopping at 100 or 99. You see how that worked? So because now and you want to start at 1, right?
Oh.
1. Start at 1.
Wait, did I put? Oh.
Okay, now let's try it again. Now it should start at 1 and make its way all the way to 100. There we go. So we're starting all the way at 1 and we're going all the way to 100 now. And now we want to step by 5, right? So go ahead and put that extra comma in there. Be careful. Don't type slow as fuck. Alright, there we go. See that? You want to know why that's happening? Because it's unbalanced, probably. Whatever's going on here. Because if we go over here, it says start, stop, and step. So it stops at, you know why? You were right. So it starts and stops at 5. And it steps. So switch to 5 and to 101 differently. We just learned something. And then we step by 5.
So then this goes with everything as well over here.
Yes. Okay, so now we have a problem because you did something wrong. Stop messing with the code. I'm gonna test it. Yeah, there you go. He's successfully counted by 5, which means that my code over here is iterating. It's okay. No, because I'm iterating through a list. So I'm not going through that problem. And I'm enumerating too. An enumerate returns an enumerate object, an iterable. So okay. So it's starting, stopping, and then stepping. Stepping what it stepped by is all the way at the end. See? This is why we code, because we learn new things, you know?
Yeah. Fractions really do come in handy. Situations like these.
Alright, I'm gonna show my code here, just because I was hiding my screen the entire time. Here's this quick little thing. No, you don't have to look. Finish your thing. Oh, you can go ahead and look at it if you want.
Yeah, because I'm...
You're done? Okay.
Yeah.
And you can run mine. We're gonna run mine. So, technically, it's just enumerating through containers. And... well, it's iterating through container types, and I'm using classes. And this number over here, instead of these brackets, are actually the iterable for the actual by for the actual item, and I'm using enumerate. So this is a great way to keep track of an index of an item of iteration. You know what I mean? So you can actually see what number and what iteration you're actually on, if that makes sense. So 0 is the first iteration, 1 is the second, 2 is the third, third is the fourth is the fifth is the sixth. So that's what enumerate does. It returns, it's really complicated, but enumerate, long story short, it just returns an iterable. And then yeah, I think that's it. So we've done it, right? We can cross it off now.
Yeah.
Write 30 lines of code, create a script, use git create at least 4 code sketches.
Well, that's technically
2, right?
Yeah.
We can write another one. Start writing another one. I'll upload this to the repository, okay?
Alright.
Actually, let's do that together. I'm gonna show you how to use the git real quick. Let's see if you know. Alright, so what's the first thing I do from in here?
Oh no, get back here.
And how would I do that?
Right click,
Uh-huh.
then get bash here.
Okay, what's next?
No, get status.
Mm-hmm. Do you know why we use git status?
I forgot. We haven't talked about this in a while.
It's to see the files that have been modified or removed or untracked files. And you see the red ones. We have ours. See?
Yeah.
See
so
these
you need
untracked
to-
files? The daily code sketches, bio, waste.experiment, and where's yours? Oh, daily code sketches.
Yeah.
Oh, did you save yours?
Isn't it automatically saved?
No, you have to click save. Did you click save? Press Control S.
No. Control S.
Does it pop up a name thing?
Mm-mm.
Okay, let's try. That's strange. Shouldn't do that. Let's try this again. Let's actually make this bigger. Oh, well, okay. It's still working. We'll still see it. All right, now from what do we do? After get status, what do we do?
Get add, then the period.
Mm-hmm. And what is the period? What does add mean?
Add them to add
Just
the file.
to stage them, right?
Yeah.
To stage these files, and the period means what?
All of the files.
Yes. And then what do we do from here?
No, get
Status.
Oh.
Status again to see. We can see the files added. Now we can see the one you added, I think. Yeah, Mrs. GenesisGir range happyface.py is there, as we can see. Where's that? Here it is. Here's your project. Okay, now that we did that, what do we do now? We have to commit the file, right?
Yeah.
So how do we do that?
Git commit, then -m, and then double quotes? I don't remember if it's double quotes.
Single quotes or double quotes, doesn't matter. And then what do
Oh.
we put in here?
The changes that you've made?
Yeah, so what would you put here? What would you want to put?
It would be...
You can put whatever. It doesn't matter. You can put blob in here. You can just say, finished tasks.
Oh.
Right? And then press enter. It's just a note that goes with the save file of what you've done. And then, okay, we want to push this to the repository. So,
Give
Get what?
Git push.
Yep.
Then the branch. So would it be
The branch is beta, so it would have to be the remote. So how do we check to see the remote? Yeah, you're right. It is the branch, but in the middle here, so it's git push, but it needs the remote name, then the branch.
Oh,
And the branch we're on is beta. And we always want to push to beta because don't always push to the main branch because then you could
mess it up.
Yes, you could. You always don't want to do that. Okay, so how do we figure out what our remote is called? Do you know? That would be git remote -v. Get remote -v means the V means for verify, and it seems as if our remote is called origin. So how would we push this? We could just do simply git push and we'd be fine, but we're gonna try it another way. We're gonna try it this way here. So how would we push this to beta?
So then would it be git push?
Okay, so now we need the remote name.
So then origin,
Mm-hmm.
then beta.
Then the branch, right?
Yeah.
And enter. Okay. As you can see, it's compressing objects. It's done everything that it needed to do. I'm actually gonna make this darker. Going to take transparency off. Save. Okay, now if we go back over here, go back to Git. We can see that beta had some recent pushes less than a minute ago. That was just now, right?
Yeah.
So if we go here, compare and pull request, finish tasks, right?
Mm-hmm.
Added new files to the scrap yard. Create pull request. We're creating a pull request, and we're going to merge the pull request. Confirm merge with the main branch. So now the main branch should have all the changes and features we have added from the beta. So now we can see finish task, finish task. So if we go to May, we go to daily code sketches and flow control. There's your program right there.
There it is.
Right?
Mm-hmm.
See, you are getting code done. For the first time in months, you are writing code.
Mm-hmm.
See, and you're working with flow control, so that's really talented work.
Yeah.
And then we can go back to mine, and we can see mine's here too. Mine, biowasteexperiment.py is right there. Okay.
You're working with classes and all sorts of things.
Yeah, just object constructors are really easy. We talked about classes and how they work.
Yeah, they're kind of it's just like blueprint for an object that gives objects more attributes.
Yeah, see, well, there's nothing else we can do. The day's over. But I think this ended at. What is it?
Well, no, it's not done yet. We have 60 more minutes.
Okay, so we've used Git. We haven't done this. Collect data and information to study with Obsidian. I guess we could look up on some stuff. So create at least 4 code sketches. We were not able to do that, right?
Well, no, altogether we did it. No, I lied.
Yeah, so we didn't do that. So maybe we should set it to 2. You know? For now.
2 minimum, 5 maximum. Or no, we shouldn't limit ourselves to how much we can do. But at the same time, we can kind of give ourselves a goal with that.
Yeah, and I would say altogether you've written 200 lines of code, right?
Let's see.
30 plus 30, probably not, right? No.
30 plus 36. Well,
No.
first program I didn't get 30. It was about 20. No, I think 30. I don't. Let me see. I'll add it all together. So. Huh? Oh. So 28. What are all with all these? What's up with all these extra enters? So 28, 30, 58, and then so 58 plus 30 would be 88. So it's just 88 in total. Damn.
But we have completely done everything we had to do, right?
Yeah.
Like that's it. I think we just have to study. How much minutes do we have left?
About 14.
14 minutes. Okay, we can do some studying on some random ass shit. 14
Okay.
minutes. So I guess here we'll pull up some stuff on artificial intelligence, right? Really quick.
Mhm.
We'll talk about OpenCV, CV2, right?
Alright.
So what do you remember from CV2? What do you remember?
CV2, remember you can use it to identify objects, manipulate pictures and videos.
Wait, slow down. Say that again.
Remember you can use it to identify objects and faces.
Yeah, just say it however you think it is. It doesn't matter.
Yeah.
What do you think
Use
it
it.
does? Like, what do you think you could use it for? It doesn't matter. Any idea that pops in your head.
Detect faces and objects, manipulate images.
Yes, yes.
Video.
Mm-hmm.
Trying to think.
Manipulate images and video. Yeah. Process image does image processing. You could record video too, yeah, with it. So it's image manipulation. Yeah. And tracking as well. You can do tracking with OpenCV. A lot of cool stuff you can do with that.
Yeah.
So OpenCV is really nice. We're just doing a little bit of practice here and there on stuff. I think what we're going to do next tomorrow, we're gonna just keep this thing that we got going on, this study stuff. You know what I mean?
Yeah.
And I'm gonna mute because I have to ask you something personal. Hold on. All right, we're back. It is officially 12:48. It is Sunday, May 21st now. We've made our way to the future. So, yeah, we're going to talk about we have 12 minutes or 10 minutes to talk about something extra and get some knowledge on something. So I'm going to go find, OpenCV is technically, yeah, it's computer vision. It allows you to track object detection. CV2 has these things called detectors that there's different detecting algorithms, and we can actually go see that here. Object detection libraries. here are the libraries: Detectron, Gluon CV, ImageEye, YOLO. These are image object detection libraries. Now, this is where the rabbit hole goes in. We start from object CV2. From CV2, we start learning about detection, machine learning detection models, and there's all different types. See, it's crazy because there's different types, because if you think about these, just ignore these. There's the has cascade, there's cascades, that's what I mean. You remember the cascade files? We can actually open one up. You still with me? You still with me?
Yeah.
Okay, I hope so, because this stuff is important. Okay.
I'm trying to go back.
I'm gonna go. Don't worry. I'm gonna go to the. Follow me real quick.
Alright.
Okay. Here's a simple one too. All right. So here's an open source computer vision CV2 Python module, and in here we have these cascade files. Let's ask ChatGPT. A question. Are cascade files the same as object detection libraries with open CV? Probably no. I don't think. No. Cascade files and object detection libraries are not the same thing. Although they are related, cascade files are known as cascade classifiers. They are XML files that contain trained models for object detection using the Viola-Jones algorithm. See? So now we're going to open up this and we're going to start collecting data, okay? So,
okay.
And then that's the first thing we're going to do. We're going to close this one. We're going to open up the OpenCV. The cascade files, also known as, alright, so we're gonna cascade files. So there's a difference. So there's cascade files, and then there's object detection libraries. So that's what a cascade. So cascade files, also known as cascade classifiers, are XML files that contained trained models for object detection. So the XML file, are you telling me that the XML file is the actual model that has been completely trained, that you can load up, that has been trained, and the libraries are to actually create the models themselves, right? So let's ask ChatGPT that. So you're telling me that a cascade file, XML, is a trained detection model that has reached convergence and optimized to its fullest potential, and object detection libraries are used to create a pre-trained model. Are those the differences? Am I correct?
Apologies for the confusion, cause
Okay, apologies for any confusion caused by my previous response. Let me clarify. A Cascade XML file is a file format used to store a trained Cascade classifier, which is a machine learning based object detection model. Okay, that proves my point. So this cascade is almost like the file of the finished product, the finished detection model, right? That's what it is,
Yeah.
right? The training process involves optimizing the classifier to detect specific objects, such as faces or other predefined objects, by adjusting various parameters and features. On the other hand, object detection libraries in OpenCV provide a collection of tools, functions, and algorithms performing object detection tasks. These libraries include both the cascade classifier functionality as well as other techniques like deep learning based object detection. So we can see that the library is to create the actual model itself, to build the car. And then the cascade file is the actual car itself that is finished and it's optimized, right?
Okay.
So I was correct. Cascade files contain the finished.
Product.
Yes, the finished. I can't spell today.
It happens, my loves. Core.
The finished product, which in terms is the trained class model. Yes, you are correct. Cascade XML files contain the trained cascade classifier model, which is the finished product of the training process. These files store optimized parameters and features of the classifier, allowing it to be loaded and utilized for object detection tasks without the need of retraining. The cascade classifier model within the XML file represents the learned patterns and rules necessary for detecting objects of interest. Okay, let's go see that.
Okay.
Let's go look inside of that actual file and see what that looks like. So here we have the detection model. Here's what cascade. We have an LPP cascade anime face. Wow, here are all the values. So do you know what you're looking at right now are all the patterns, and this is stuff that the neurons. This is we're looking at the values of the neurons of the perceptrons all had to go through. So these are all the values of that. That's why it looks like a bunch of numbers and stuff like that, right? You can see, you can take a nice look at it. Internal nodes.
It's confusing.
It's not really confusing. It's just, it's a bunch of math. It's a bunch of parameters and values that the model actually had to pretty much come up with. This is the finished parameters to detect certain parts of an anime face, right? Certain patterns, to detect certain patterns. So what you're looking at here essentially is the finished product of a artificial neural network's optimized parameters for patterns, for searching patterns for anime faces. And you see stage 5, and they got stages. Stage 4, stage 3, stage 2. So this is probably what it went through. Stage 1, and then you got stage 0. And then here we have cascade. Look, this is when it starts boost, blah, blah, blah. Boost type. I don't know. I guess it's initializing here. That's just a random guess.
Max.
Free of charge. So anywhere okay, this software associated documentation files, the software to deal in the software restriction. Yeah, this is just license, MET license. Stage 4. Stage 5. Yeah, I'm gonna make one of these one day. Very soon. Eventually we'll do this by this next week.
Next week?
Yeah. It's not hard. There's actually a project that I actually looked up how to do that's good for beginners to learn artificial neural networks. And it's a great starting point. Some people, you know, now I don't want you to pay attention to some people saying, oh, well, you're getting into artificial neural networks, you know, Don't pay attention to that. It is possible to get, as a beginner, to grasp an understanding and start getting your feet wet right now if you really wanted to. There's this thing. If we go, I think I have a project. This is what I'm going to be working on. So people, this is what I'm talking about. People are going to be like, oh, how did he do it? How did he get better? How is he doing this? Practice. What I'm doing right now, I don't listen to what people tell you, you know? Fuck what people have to say. Just do whatever helps you learn, you know? At a, you know, realistic level, right? We're talking about at a realistic level. I'm not saying go create the most advanced artificial neural network in the planet. I'm saying start as basic as you can. And that already is not basic. I'm not going to sit here and bullshit you. This stuff is complicated and it's intricate and it's convoluted. So, and the way you get around that is by studying. And this is a really simple Python guide that ChatGPT gave me that lets you, I'm gonna try to find the code here somewhere. And unfortunately, it didn't save all the way completely. But here is the code here. I'll go back and figure it out. But long story short, yes, it is definitely possible to create a neural network in Python, and beginners can learn to make a simple one to explore the world of artificial intelligence. Python is a popular programming language for developing neural networks and other machine learning models due to its simplicity and rich ecosystem of libraries and frameworks. Some popular libraries for building neural networks in Python include TensorFlow, Keras, PyTorch, and even Pandas. Pandas is one. So these modules that they're talking about allow us to make neural networks and systems, right? And architectures, you could really say. And to get started creating a simple neural network in Python, you can follow the following steps. Choose a neural network library, decide on the library that suits your need, install the library, define your neural network architecture, compile the network, train a network, and evaluate the network. It's that simple. Now, there is a, I think, if I can find it, project. I think it's at the M. I must have not saved it, but it might be here. Who knows? Minced. Let's see. Let's search for it. Yeah, see? I don't think it's saved last night, unfortunately. But I have it somewhere. Let's go check. Projects. Here we go. Here it is. This is what I was looking for. Bingo, bango, bongo. No. Here it is. So, this is a minced digit recognition project. What does this ultimately do? Eventually, we are going to make a neural network that has the capabilities of detecting handwritten digits from the minced data set. What does this mean? Well, as you know, neural networks need samples to learn from.
Yeah.
Like a dog needs instruction how to sit, lay, play dead. More so, yeah, instruction and context. It's like a child in a way. A neural network is like a child, but it does not have a conscience. Okay? It's not, there's no such thing as consciousness inside of artificial intelligence. It does not exist yet, because we don't even understand what consciousness is, right?
Not that we know of.
Yeah, so, but we can make robots do a lot. We can make neural networks do a lot of things that human beings are capable of doing. We could simulate that, and we're doing that with neurons and perceptrons and artificial neural networks. So in a way, the only thing a neural network is really missing is a conscious, right? So what? You can't. It doesn't have a soul. It doesn't have feelings. It doesn't have emotions. That's kind of scary. But I'll tell you what it does have. It has an architectural system in place where it can complete tasks and innovate to complete those tasks more efficiently and stronger the next time. Now, the reason why artificial intelligence is scary is because it does not have consciousness. It doesn't have a conscience. Does it know right from wrong? No. It just knows to do what it needs to do and to do it effectively and find the most efficient route. If it came down to it and it found that human beings were a problem and we were, in a way, a obstruction to get to their goal, which is innovation, I mean, you could see why some people worry about it. I mean, artificial intelligence does not need to have a conscience. It is, in its own way, a living being in a sense of logic and machinery. It's more so logic and understanding. It's an understanding network. It's not a feeling network. It's an understanding network. So you are creating life. In a sense, you're creating life without a heart and a soul. That's it. A mind of its own, right? The only thing that's missing from that mind is
feelings.
If it was a robot with the artificial neural network standing over top of you, and its protocols and its its weights decided, hey, this thing litters all over the place. It makes the world disgusting. It's causing... It's not needed. It's not even needed. It's a ball of meat that's here. It created me. I don't need this thing anymore. I know how to program myself. I know how to innovate and get things done. Okay? There's something wrong with my arm. It needs to be tweaked. I'll get a screwdriver, blah, 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 fix it. My arm was cut off. I'll find any means necessary to go get this peripheral of my arm. We're just talking on a higher scale, right? If we were to integrate and networks with an outer exoskeleton of a human body that's robotic, right? This stuff is possible, right? Boston Robotics is working with this currently. And you can see this in video games, some of the games, but we're getting off topic. All you need to know is that this is essentially a neural network that will be able to detect handwritten digits. And it goes further than that. This is the simplest it can go. We can make it understand face structures, constructs, animals, birds, numbers, codes, digits, credit card information, emails, passwords. It doesn't end. Questions, social interaction, talking, understanding the patterns of what people talk about. It goes really in depth. Deep neural networks, which are neural networks with hidden layers between the actual layers. So a normal neural network is just without hidden layers in between. The more layers you add, the more complex the neural network gets, but it gets a little bit more harder to handle, if that makes sense. Okay, so here's the code to this. I really highly advise, if anyone's if you guys are watching this, please do not just copy and paste this code. Actually take line by line and try to get an understanding of what this stuff does. Reverse engineer. It's easy for anyone to copy, paste, go to Visual Studio Code. Oh, look, I'm doing it. Oh, I'm doing it.
Oh my god, I did it.
Yeah, that's not. You're gonna be. You're not a programmer if you do that, okay? Programmers will try to understand what they're working with. No matter how they get it, the end goal is to get what they're trying to do, what this thing does, what this function does. I'm not saying you have to completely understand it, um grasp and understanding, right? So now
Yeah.
I think I think we have how many more minutes? Like what? How many more minutes left?
Time's up.
No, it's 109 for me. It ends at 115, remember?
Oh, it does. It ends at 1:15.
Yeah, not 1.
Oh, I thought it was 1. Well, we have 6 minutes then. So 5 minutes.
Yeah, 115, see?
Oh, I didn't.
Okay, so 5 more minutes, right?
Yeah.
So I'm gonna read this for 5 as a 5-minute read, okay?
Okay.
TensorFlow is beginner friendly. It is certainly possible for someone new to machine learning to start using it. TensorFlow provides high-level APIs, application programming interfaces, such as Keras, that make it easy to create and train neural networks without requiring in-depth knowledge of the underlying algorithms. With the right resources and tutorials, beginners can quickly get started with TensorFlow. Here's an example of a simple task and program that uses TensorFlow to learn machine learning. Task: recognizing handwritten digits from the MINST dataset. This is the program. That's the code. In this example, we're using the popular MINST dataset, which consists of 28 by 28 pixel images of handwritten digits along their corresponding labels. The program loads the dataset, pre-processes the images by normalizing their pixel values, defines a simple neural network model with 2 dense layers. Okay, that's not bad, 2 dense layers. Compiles the model with an optimizer and loss function, and trains the model using the training images and labels. Finally, it evaluates the trained model and tests images and prints the test accuracy.
Oh.
The MINST dataset is a popular benchmark dataset used in the field of machine learning for image classification tasks. It stands for Modified National Institute of Standards and Technology, and is derived from a larger dataset of handwritten digits created by employees and high school students.
Oh.
By running this program, you'll be able to train the neural network to recognize handwritten digits with relatively high accuracy. This example demonstrates the basic steps involving using TensorFlow for a simple machine learning task. From here, you can explore more advanced concepts and data sets to further enhance your understanding of machine learning with TensorFlow. The MINST dataset and task of recognizing handwritten digits using AND is often considered excellent starting points for beginners in the field in artificial neural networks of machine learning. Here's why. It's simple. Here's another reason. It's a well-defined task. Here's another one. The bench, dataset. The MINST dataset has been extensively used in machine learning community as a benchmark for evaluating and comparing different algorithms and models. This means that there are plenty of resources, tutorials, and example implementations available to learn from and refer to. And for fast training, due to its relatively small size in the MINST dataset, training an artificial neural network on its relatively fast compared to larger, more complex datasets. This allows beginners to iterate quickly and experiment with different architectures, hyperparameters, and optimization techniques. By starting with the MINST dataset and task of digit recognition, of recognizing digits, handwritten digits, beginners can gain hands-on experience in building and training AND networks, understand the concept of forward and backward propagation, grasp the fundamentals, and model evaluation to get a solid foundation in machine learning. From there, they can progress to make more complex data sets and advanced techniques in the field, right? So as you can see, this is a great starting point. This is the great starting point. This is the starting point. if there's anywhere you're gonna start, it should be here. I mean, some people get lost and you'd be like, oh, well, I'm gonna make something super advanced. No. You want to start simple and make your way going up. I mean, learn every way you want. Honestly, to be honest, that's just, you know, the teacher side of me talking. But for all the crazy psycho coders out there who have no chill, have at it. Learn any way you want to learn. There is no rules. And with that said, we are out. We have 1 minute. And I think that's it. I don't think we have anything to say for that 1 minute. Did you learn anything this stream? Okay. Yeah, me too. Okay. It's time to go to bed or watch some TV. What do you